Hey, hello everyone. Am I audible? Can anyone please confirm with me? Yes, am I audible?
Yes, ma'am.
Okay, perfect. Okay, so I think we can start now. Let me share my screen first. Uh, Chat is disabled. Let me see how. So, okay, you can write your questions in this Q&A, which I can see. And accordingly, I'll take the questions from you all, okay? So at each and every time, whenever I am teaching you something, so what I usually do is that I will try to give you the time in between. And at that point of time, you can ask me the questions whatsoever you have. Fine? Okay. Shall we start now? Is everyone ready? Yes, Bhargava, do you have any concerns?
No, ma'am. It's all right. We can
Please
get started.
lower down your hand. So uh, everyone, uh, whenever I am teaching you something, after that I'll ask you the questions. At that point of time, what you need to do is that you need to just raise your hand, and one by one I will just allow you to talk. Okay, so okay, let's get started now. I hope everyone is excited, right? It's okay if chat is disabled. You can question me in this chat window, which Q&A window we will discuss here itself. From the next session, I'll say to the team that they will enable that chat window as well. Okay, so let's get started. So in today's as we have the first session, and maximum students might be the one who are not already aware about what is actually DSA. So we will start with the concept of what is data structure, what is algorithm, and then step by step, we will talk about the further things related to data structure and algorithms. So let's get started with the very first definition of our class, which is what is algorithms. So what do you think is known as algorithm? Any any answers? Anyone? What do you think is an algorithm? So I'm getting some responses as well. So here, step-by-step procedure to solve a problem, or a set of instructions, or a set of processes, set of instructions to perform some specific task. Yes. Uh, just give me a second. Can you guys check once now? Chat is enabled. Perfect, perfect, perfect. Great. Okay then. So whatsoever definitions you guys gave to me about the algorithms, it's all correct. So basically, what we can say is that what is an algorithm? It's a sequence of steps which is basically used to perform some specific task. So I can write that yes, algorithm is something. So whenever we listen this word as algorithm, it is something which is a sequence of steps. But now these steps should be, I'm adding one more term here, sequence of finite steps to perform some specific task. For example, any example? For example, I want to multiply two numbers. So I want to teach to a student who is not having any idea about programming. Everyone knows how we can multiply two numbers, right? So given two numbers, for example, A and B, which is entered by the user, if suppose I will tell you, can you tell me the sum steps, which are a proper first, second, and third, to give me a number, which is a multiplication of A and B? So you can say, why not? What you can do is that as a very first step, what you can do, you will take two numbers, which will be entered by the users, which is A and B, right? Take two numbers, which is A and B, entered by the user. After that, what we are trying to do is that we are taking some other variable, which is basically used to store the product of these two numbers, which is maybe C, which is basically using a multiplication of A into B. And finally, as a third step, we are returning that value of C. Now, if you will see, this is a some finite steps. Step number one, taking of two numbers. Step number two, multiplication of those two numbers. Step number three, returning of that variable. So this is something which we called as a algorithm. This is what we made algorithm. For what? Which task we are performing here? For multiplying two numbers. For the multiplication of two numbers. Can I say? Very simple, right? Now, given a set of algorithms, can we say whenever we are writing any of the code, whenever you see in any programming language, any of the code, can you say every code as an algorithm? Or do we have some specific properties of the algorithms? So yes, we can't say that every code written in any of the programming language is an algorithm. We have some specific properties of an algorithm that we want to see here. So I hope that the definition is clear to everyone, right? So now let's move ahead. Here, now the next important part that we want to see here is that here, if we want to see what are the properties of an algorithms that we have. So let's talk about the properties of an algorithm. So the very first property that we have in an algorithm is that it should terminate after some point of time. If suppose you have written any kind of algorithm, it should not be like that, that it is keep on running. Your code is keep on running. It is not generating any output. So first property, the very first property of an algorithm is that it should terminate. It should terminate after finite amount of time. It should terminate after finite amount of time. Fine. The second important property is that once it will get terminated, it should produce at least one output. Your code or your algorithm should produce at least one output. You can expect more than one output as well, but obviously you are writing the code, you're writing any algorithm. What's the reason behind that? You want some specific output, right? For example, here I have written the code for multiplication of two numbers. So what I want is that I want a result as a multiplication of A and B. So our code should produce at least one output here, right? The third important property which you need to understand here is that it is independent of any programming language. It is independent of any programming language. Now, this point is very interesting and is very much helpful for you all. Why? Because I have listened a lot of queries from the students. Which programming language should I start to learn algorithms? What I'm saying, it is independent of any programming language. This is the property of an algorithm. Means you can start with any of the programming language, whatever you want. It's just the logic that you are building here. That's what I used to say at each and every time. And in the induction session also, I said the same thing, right? So it doesn't matter which programming language we are using here. It is independent of any programming language. Next important point. Whatever code or whatever algorithm you're writing here, it should be unambiguous. What is the meaning of unambiguous? Anyone? The fourth property which I am saying is unambiguous. Unambiguous. What is the meaning of that? Who will tell me? Okay, so I'm getting a lot of answers. So whenever we are talking about unambiguous, means the simple meaning is that the output that you are getting from an algorithm should be deterministic. Should be deterministic. What does that mean? The simple meaning is that for a given input, for example, you are writing here that I want to multiply, you have written some code for multiplication of two numbers, and you are taking the numbers 2 and 3. Today you are getting output as 6, which is perfectly fine. Now, if the same code you are running after 2 days back, 2 into 3, you are again getting the same output. You should get the same output, right? So here, the important point here to understand is that the output should be unambiguous. Means that today, if I am running the code, I am getting the output. Tomorrow also, if I run the same code, I will getting the same output, which is the apt output. Correct, everyone? So if suppose you're getting the same output at each and every time after running your code, then you can say that your code is deterministic code. Otherwise, you can say that it's a undeterministic code, right? Am I making sense to everyone? For example, you are running today the code of 2 into 3, it is giving us 6. But again, if you're running, it is giving us some random number like 10, then 12. It means that your code is not a deterministic code. And that kind of algorithm we are not expecting. If this kind of result is coming up, it means that it's not a valid algorithm. Fine. So these are the 4 important properties of any of the algorithm, which you will see in future classes. And whenever you will develop your own, I would say, algorithm also, at that point of time, you need to understand that these 4 properties should be there for any of the algorithms. Right? Results, yes, results should not be changing even if you are changing the time. Means even if you are running it today, tomorrow, day, after year, after so many, means any number of time, it should be deterministic. Right? Point 2 says that your code should produce at least one output. For example, your need today is just to multiply 2 numbers, which is 2 into 3. So it will exactly give you one answer, right? Suppose your need is to generate 2 outputs. For example, one is the multiplication of a number. Another one is the division of 2 numbers. The division of 2 numbers. Right? So at that point of time, it will return two things. So what I'm saying is that whenever you're writing some algorithm, meaningful algorithm is the one who's having at least one output. So what is the use case? Use case is to generate two outputs, so it should produce both of the outputs. That's the internal meaning of point number 2, right? So here, if you will see, these are the few properties that we have understood. Fine. So now we know what is algorithm. We have understood the example of that, and we have seen what are the properties of that. Now, if it is clear to everyone, let me ask with you one simple question. Is everyone aware about the working of the loops? How basically while loop will work? Everyone knows? Perfect. Okay. So suppose if I am saying while, as of now, don't focus much about the programming languages. I am just writing as a pseudocode. While, suppose there is some condition, something is there where I am saying because of that, that condition will be true. And inside that, I am printing some statement. Suppose I am printing my name. My name is Priya Bhatia. Fine. So this is a kind of a code which I have written. Okay. This is a code which is written in maybe Python programming language or any of the programming language. You have written this code. Perfectly fine. Can you tell me, is this code which I am writing down here will be a valid algorithm or not? Can you categorize it as a valid algorithm or not? Many people are saying no, but there are some students who are saying yes. Why yes? Why yes? Why it is a valid one? It's no. It's straightforward. It's not an algorithm. This is not a valid algorithm. Who will give me the reason? Why is that so? Because if you will see what is the property of an algorithm, it should terminate after finite amount of time. See, we are writing finite steps. That is fine, right? Task is to basically print my name, Priya Bhatia, but it is not following the point number 1 property. Here, if you will see, at each and every time when while loop will run, I am saying that the condition will always be true. And when the condition will always be true, it will keep on repeating my name. It will keep on printing my name. And that's why it will not stop. It will not terminate after some finite amount of time. That's why it's not a valid algorithm. Am I making sense to everyone? Are the properties of algorithms clear to everyone? So now in future, whenever you're writing some code, take one thing as a very note, which is a very important point from this key session, that whenever you are writing any algorithm, you need to see the terminating condition. That at what point of time your code should stop. Whenever you're writing any of the new algorithm, see, is your code is not run. It's not like that. It should not go towards infinite loop. Maximum number of times people face one error whenever they're writing a code called as TLE, time limit exceeded. Why? Because maximum number of times they forgot to mention the terminating condition, and your code will keep on going towards the infinite loop and will not stop at one point of time, right? Okay, now let's move ahead towards the next part. We know now what is an algorithm. We know now that what are the properties of an algorithm. Now we want to understand that what are the steps which are required to construct any algorithm. So the next important point which we want to understand is that what are the important steps which are required to construct an algorithm. Now, these steps will help you in future classes when we talk about the actual modules of an algorithm. So these steps we will follow, starting from very first to the very end. What are those steps? The very first important thing is the problem definition. Problem definition means you need to understand end to end that what is the problem statement all about. You should be very clear about the problem definition. For example, what particular use case you want to solve. For example, I am saying that I am giving you a list of numbers and I want a sorted list. So what is the use case here? That given a set of list of numbers, what I want is I want a sorted array, means either in increasing order or in decreasing order. That is the problem definition that you need to understand. You need to also see that what are the constraints given to you in that problem. Means whether the interviewer or whether the problem who is giving your problem is saying that is there any limit on the numbers? Is it the case that the numbers should be less than 1000, 10,000 and so on? According to that, you need to decide what kind of algorithm and data structure you need to use. So first thing is understanding of the problem definition. Now, once you will be able to understand the problem, second step is now you know what are the things which are given to you and what is the expectations from you. According to that, you need to design the algorithm. You need to design the algorithm. Now, there are so many ways to design an algorithm. What are those? There are so many ways to design any algorithm. The very first way is maybe using divide and conquer. So whatever names I am writing down here, as of now, just for the sake of seeing that there are multiple approaches to design any algorithm. And in our course, we will try to see all the different kinds of approaches. But as it's your first session and many of them are beginners, so just see that, okay, these are the approaches with the help of which we can design the algorithm. Apart from that, maybe you will be having, you are solving or designing your algo using a greedy algorithm, or using a dynamic programming, or maybe using a backtracking, and many more. So let me write here many more, because it might be the case that for maximum of them, these words are not making any sense. So what I want to say here is that the second important part after understanding the problem definition is to see that what is the proper way, what is the proper approach should I follow to design that algorithm. So once that is done, suppose you will be able to get an idea that, okay, with the help of this way, I will be able to solve my problem pretty well. Now you can ask me the question, how will I get to know? So once we will be able to complete all these modules, automatically you will get an understanding that at what point of time and at what pattern of questions, which particular approach is pretty useful, right? Now, the next part after designing the algorithm is, the third step is that you need to draw the flow chart. You need to draw the flow chart where there is a end-to-end, everything will be here. Starting from what is the test case, what is the input that you are taking, and what is the approach that you are applying. And after applying the approach, what is the output you will be able to get. You will be properly drawing one flow chart here to see that whether the approach that you are thinking in your head is pretty much helpful in your question or not. Once you will be able to finalize that, and you will be able to just get the justification by drawing the flow chart, the next important step here is to do the testing now. So here comes the testing phase. So here, if you will see, what will happen is that whatsoever input you have written down, after applying your approach, are you getting the correct output or not? So usually what happened, for every question, you will be providing the problem statement, then you will be providing few test cases. In the test cases, if you will observe, for every interview-based question, you will be having the input, and corresponding to that input, you will be having the output. And similar to that, you will be having 3 or 4 test cases. It might vary platform to platform. Now, what you need to observe here is that you need to see that for every input that you are passing, are you getting the correct output or not? So, if your approach is correct, if your way of thinking the question is correct, then obviously, for sure, you will be able to get for every input the correct output. And you will be able to confirm yourself that whatsoever approach you are using here is fine. And once you will be able to get that confirmation, then is the next step where you will start doing the implementation. When you will start doing the implementation. Now, here if you will see, when I'm talking about implementation, can you observe here that this is the fifth step which I'm writing down while constructing any algorithm. But what is the one of the very first mistake which many students do? Whenever they get the code, whenever they get the question, whenever they get the problem definition, they directly jump to start writing the code. They don't even think, or they don't even want to spend any time over it to see that what kind of approach they will apply. And after that, they just randomly doing something, and they will be able to get something out of that. And then they will be like that, I'm not getting a correct output. You need to spend a lot of time before doing the implementation. Now, this implementation, as I told you, it doesn't matter which programming language you are using. Algorithm is completely independent of any programming language. You can do the implementation with the help of any language. Programming language is just a tool to demonstrate that whatsoever approach you are applying is correct or not. Whatsoever logic you are applying is pretty much fine here or not for the given problem definition. And once that implementation is done, the last phase, which is coming into picture, is called as analysis. Analysis. What does that mean? Now, suppose that there are various students, and I want to pick one out of them who is giving me the best solution. So basically, in order to solve for any problem, there are so many solutions that we have. So for any problem P1, consider that we will be having so many solutions. We have solution S1, we have solution S2, we have solution S3. Now, out of these three solutions, how can I compare that which particular solution is correct? I have three students, everyone is getting the output. So in testing phase, everyone is getting the correct output. For example, I want a factorial of a number. I want a factorial of any number. Okay. For example, when we are talking about 3 factorial, factorial is 3 multiplied by lesser digit, which is 2 into 1, which is equals to 6. So for this code, I am saying to all these 3 students that just give me the factorial of a number. So when I am inputting 3 factorial in every code, I am getting the correct output as 6. But now, how should I decide that which particular code is the optimized code? Which particular code is the one where I will give the more preference as comparable to other codes? That is done with the help of this analysis. So analysis is helpful when we want to compare multiple solutions for a given problem. In analysis, we have 2 components. One is called as time complexity, and another one is called as space complexity. And today, our complete discussion will be on this part. So majorly, if you will be able to understand the analysis module, so today we will start that analysis module. After that, if you will be able to understand this module, design algorithm, then every other step is very easy for you all. So today we will start this analysis module, and we will discuss in very much depth that what is this analysis all about, what is the meaning of time complexity, what is the meaning of space complexity, and how basically we can compare the multiple solutions of a given problem and which particular solution we can say is the optimized one. Before I will move ahead, now you can ask me the question. Point number 6. Point number 6 is the name is analysis. Means whatsoever code you have written, whatsoever logic that you have written, you want to analyze that. Now suppose I am having 3 students and all these 3 students are solving the same problem of factorial of a number. Obviously, student 1 have written some different logic, S2 have written some different logic, S3 have written some different logic for a same problem, that is to find out the factorial of a number. Now, I will do the analysis of each and every code. I will see that which particular code is having a lesser time and space complexity. What is the meaning of this? Time complexity. In simple terms, if I will talk about the code which is taking a less time to run, to generate me the output, is the better one. Can I say? Suppose S1 is the solution which is maybe giving me the answer in 100 milliseconds. S2 is the solution which is giving me the answer in 50 milliseconds. S3 is the solution which is giving me the answer in 20 milliseconds. Now, what do you think? Which code should be more preferable? Every code is giving me the answer as 6, but it is giving me in the lesser time. So what we want in our code is we want always lesser time complexity. Less time to execute that code. Similarly, we want, so space complexity is how much extra space you are using in the system to execute the code. So again, suppose for this particular code, you are using some extra space, maybe 5 MB. But here you are not using any extra space. Here, suppose you're not using any extra space. So which particular code is better one? Which is not using any extra space and is having a lesser time complexity, right? So space complexity is also what we want as a lesser. So that is the layman term meaning of time and space complexity. But in terms of algorithm, we define it in the sense of notations that we will talk about in the later part of our session. But as of now, whatsoever things we have discussed is clear or not. One good question, which I will come into that question as well, that, okay, I have just talked about that in an analysis, we have 2 components. One is the time complexity part, another one is the space complexity part. Time complexity is how much time is required to execute that code. Space complexity is how much extra space we are using to execute the code. Fine. But now, which one is more preferable? Which one is more preferable? Suppose, given that, for example, I'm saying that in 100 milliseconds code, it is not taking any space, extra space. But this particular S3 solution is running in 20 milliseconds, but is taking some extra space here. So what do you think? So here, they are not using any space. So there is no extra space is used here. So which one should be more preferable now? Will you go for S1 or you will go for S3? So now try to understand here. There is always a trade-off between time and space. Always you will see in maximum scenarios, when you are in, your time is high, there is no space requirement. But when you are moving towards the higher space requirement, somehow time will be automatically reduced. Now you can think of a scenario where, suppose you are running or you are giving some query in the Google. Will you wait? Do you have that much patience, at least nowadays, to wait and to see that what is the result it is giving to us? We want instant results. We want that whatsoever query we are commanding to the system, it will give me the correct result immediately. So always remember, time is something more superior than the space. Because for space, we have so many things nowadays, so many hard disks are there. We have the secondary memory also, where we can store a lot of data. But for time, no one wants to compromise, right? That is the specialty of the supercomputers. Instantly, we will be able to get the results. That's why, because of this speed itself, their pricing is very high, right? So we don't want to compromise over time. No one wants to compromise over time. So always remember, so if suppose someone is saying that I have a code which is having a lower time complexity and lower space complexity, that's well and good. But if suppose someone is saying that I'm having a code whose time complexity is high, but I'm not using any space, versus the code whose time complexity is low, but we're using a space, the preference will be given more to this solution. Because time is more precious as comparable to space nowadays. That's the ultimate reality that we have to understand, right? So here, in maximum instances, that is the scenario that you have to follow. And that's why in all our complete course, whenever I'm writing any of the code, you will see that pattern, that whenever we are implementing any of the code, either in Python or JavaScript programming language, what we are trying to do is that after doing the implementation, we will see the thing called analysis. We will see what is the time and the space complexity required in that code. We will see specifically the time complexity requirement, that we want the code to be having a very less time complexity. And that's the ultimate story and the target, which will keep on going until the duration of this course. And even whenever you're solving any code, that is the ultimate thing you have to see. You can solve one question. So let me give you one genuine example here. Suppose I am saying that I am having natural numbers, 10 natural numbers. So I am having 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. For one person, so there are two students in my class. So let me name some person, maybe Dharun and Arvind. So these are the two people, students in my class. So I am saying to Dharun, and then there is one team of Arvind. Okay. Now these two people are there. I'm assigning the same task to both of them. I'm saying that give me the sum of 10 natural numbers. Okay. Give me the sum of 10 natural numbers. Now, Dharun says that it's very easy, ma'am. What I can do is that I will use one for loop. I will use one for loop whose value will start from this and will end until this. And I can take one variable, maybe total or maybe the sum, which is equals to 0. And now when my loop will keep on moving, I will just keep on adding the numbers. So sum plus is equals to, suppose you are having that, you are storing it inside one array. So you are saying arr of I. Simple. I am saying it's very fine. So basically he is using one for loop whose value will start from 0 and he is moving until the value of n minus 1. This is one way. But Arvind says, so with the help of this, I got the answer, which is the correct answer. So in the test case, the answer is correct. Good. Now Arvind came to me. He said that, ma'am, I can also solve this problem. But what I will do is that I will use the formula which I usually study in my 9th and 10th classes, which is the formula of sum of n natural numbers. Anyone tell me what is the formula? What is the formula of sum of n natural numbers? N into n plus 1 by 2. So I told him it's amazing. So he said that you are saying 10. So what I will do is that I will simply do 10 into 11 by 2. So it will be 55. Now I am saying that, okay, this answer is also correct. This answer is also correct. So here, the important point here to understand is that both of them are correct. So this is the approach solution number 1. This is the solution number 2. and both of them are equally correct. But now the question is, which one is better performing? Which one, which approach, S1 or S2, is the best one, and why? Now, these kind of answers you will only able to get, or these kind of justifications you will only able to get once you will be having a knowledge of this analysis module. Because there we will see that which particular code will take the lesser time and space complexity. So always what is our target in every question? Target is to have, to achieve lesser time and the space complexity. So once you will be able to understand that how I will be able to get the time and space complexity, then it will be very easy for you to talk about the same thing. So am I making sense to everyone? So we are leaving this part as it is. I will come over this again when I will completely done with the analysis part. Then I will ask from you that which one is better and why. As of now, maybe there are so many students who are not aware about the fact of this time and space complexity. So first of all, I will explain that part. And then I will again ask the same question to you. And then you will tell me that, okay, both of the approaches are correct. Which one is better? Justification of that, right? Yes, we will be given time and space. If we both have, both of them will be lower, it's perfect. It's very good. But given more preference, time will be the having a higher priority. Here I am not using any programming language till now. And even when we are talking about analysis module, I will not use any programming language. I am just writing some simple pseudocode kind of thing, right? Whether it be Python, you can assume by Python, C++, JavaScript, any programming language you can assume here. When we will move towards the designing part, and when we actually start writing the code, at that point of time, the programming language will come into picture. So don't worry about programming language as of now in the initial sessions. Right? Any doubt, anyone? We have so much memory. I'm saying that we need to focus on both time and space. But given time and space, which one is more superior? I'm saying time. Right? Okay. Now, when I was explaining you about the time complexity, I have just written down these numbers in terms of milliseconds. But actually, time complexity and space complexity will be represented in terms of something called as asymptotic notations. Asymptotic notations. We will talk about these notations in very much depth in the later part of our session. But just as a brief overview, there are three different notations that we have in our algorithms. One is called as big O, one is called as omega, and one is called as theta. Big O is the one which will take care of the worst case scenario. What does that mean? Worst case scenario meaning that when you are having a lot of data, when you are having a lot of huge amount of number, at that point of time, is your code is working fine or not? Omega will take care of the best case scenario. When you are having a small set of numbers, or depending upon use case also, these scenarios will get changed. I will let you know whenever we are talking about any of the problem. And theta is, in other words, known as average case scenario. These are the representations or the notations with the help of which we will represent any time and space complexity. So let me give you one practical example here. Suppose you are having one friend, you want to see the actual reality of that friend. So when will you see? Means when you are having a good time in your life, at that point of time, is your friend is supporting you? When you are having a average case time in your life, at that point of time, is your friend supporting you? That is called a real friend or a fake friend. Or when you are in your worst case, at that point of time, is he or she is there or not to support you? In worst case, right? So best and average is fine, but if that friend supports you in your worst time also, automatically can I say that he will support you in your best and the average time also? Right? So if I want to see the reality of any person, usually people say, right, that whenever bad time comes, at that point of time, whosoever is with you is your actual friends or actual relations. So why we used to say that? Because in that worst case scenario, if they're supporting you, then automatically in the best and the average case scenario, they will support you in your life. So same goes with the code as well. So we always worry about the worst case scenario. If my code is able to run in the worst case scenario, automatically can I say that code will be equally valuable or equally it will work for the best and the average case scenario? Can I say? So always we will try to see whenever we are writing a code that what is the big O time complexity of our code. What is the big O time complexity of our code? This is the very important thing that you need to understand. Because I know that if my code is running in a good way, in the worst case scenario, automatically it will work good in the best and the average case scenario. What is that? Mathematical intuition behind that. We will talk about that in very much depth. Maybe not today, then tomorrow. But that is the important thing that you need to understand as of now, whatsoever I'm saying. Right? Now the question is how we can basically check what is the big O time complexity of any code. How we can see. So before going towards that part, so step by step, we are moving towards that part only. So now before moving towards that, I want to tell you that there are mainly two different types of analysis we have, which people usually don't know. So whenever we are talking about analysis, we usually have two different kinds of analysis. One is called as posteriori analysis and one is called as priori analysis. Posteriori analysis and another one is called as priori analysis. What is the meaning of posteriori analysis? This analysis is completely dependent on the type of hardware that you are using. So it is completely dependent on what is the language of compiler and the type of hardware that you are using. But when we talk about this priori analysis, it is independent of both of these things. It says that I don't care that which compiler you are using. I don't care which hardware you are using. I just only concerned about the logic that you are giving to me. In a priori analysis, we always talk about approximations. We always give the approximate answers. We are never ever worried for the exact answers. Whereas in posterior analysis, we always work for the exact results. So when I'm saying big O notation came into this picture. So with the help of this big O notation, we will be able to give the approximate analysis of my code. So here, what analysis we will do in our classes? We will focus on priori analysis. Because obviously everyone is not that much superior to buy a very good hardware to generate the exact results. But everyone is having that super brain in their head with the help of which they can write a Nice logic. And a priori says that I just focus on the logic. I don't care what hardware you are using, whether you are using any i7 machine or any i3 machine. If your logic is good, I will give you the response. If your logic is bad, I will always generate a bad result. That's it. So what I am talking about, that if suppose in future someone is asking to you that which analysis you are doing here, your answer should be priori analysis. Why? Because it is independent on the language of compiler and the type of hardware. Whether I will implement on any of the language, whether I will implement on any of the machine, if my logic is good, if my logic is very nice, it will produce a nice result. If my logic is bad, it will produce a bad result. That's the thing. How you can generate those approximate answers using the logic? With the help of a notation called as big O notation. Simple. Fine, everyone. Any doubt so far? So good? Crystal clear? That's amazing. So one person is saying repetition of this same again. So let me repeat it again. If there is someone who is not able to get any of the point, you can, if you will tell me 10 times repetition, I will do 10 times repetition. But whosoever is there in the live session, I always want in my batch, every bit of whatsoever I am teaching should be clear to each and every student, specifically to those who are beginner in this, who don't know what is algorithm, because I am expecting maybe various students are already aware about all these concepts, but what's the logic behind starting from a very scratch? The only logic is that everyone should be at the same pace, so that when we will try to cover up the advanced things, everyone can easily cope up because their fundamentals are strong, right? So the last point which I was saying is that we have seen what is analysis, right? Analysis is the very last step while constructing the algorithms. Now I am saying that we are having two broader categories of analysis. One is called as posteriori analysis. Another one is called as priori analysis. Posteriori says, so there are two ways to analyze. One way is that you are writing some code and you are writing on the supercomputer and it is running fast. But when you are changing the hardware from supercomputer to i3 machine, it is taking several months to produce the output. That is one way to analyze the code. Now, the important thing logically to understand that we are not having that much money as a student to buy those supercomputers to run the code, right? But everyone can write the super logic. So there comes another type of analysis called as priori analysis, which says that I don't care what hardware you're using. I don't care about the language of the compiler. What I care about the logic thing, only the logic. So here, via writing the logic, we will just try to see the approximate answers in the a priori analysis. And that is what we will try to do in our next part of our today's session. I will try to show you that how basically we will be able to calculate these approximate answers or the big O notation in our code. We will never ever worry about this posteriori part. We don't care what is the kind of a hardware we are using. Everyone has its own system. But what we are caring about in our course, nice logic. We need to write a logic in such a way that the approximate answers that we are getting should be highly optimized. Making sense? Perfect. Okay, now let's move ahead. In real time also, we will be going towards the priori analysis. Fine. Now let's talk about more in depth about this discussion of big O notation, which we have started. How basically we will be able to compute the time complexity. And what is basically the time complexity all about? Fine. So when we talk about this, so now we are moving in much depth towards this priori analysis. What it says, it is something which you can say is the order of magnitude of a statement. I know this statement is quite confusing. I will explain to you what I am saying here. What is the meaning of this? Try to pay attention now, because from this part, a very important and very crucial concept is coming into picture, which is related to algorithms. And if there is someone who missed this and is coming after 2 or 3 sessions, he will not able to regain that continuity, which you guys will gain. So be very attentive in the session now. So when I'm saying a priori analysis, it is something which is the order of magnitude of a statement. What does that mean? Simple meaning is that whenever you're writing any code, you need to check that how many number of times that statement is repeating. Whenever you're writing any of the code, you need to understand how many times any statement is repeating. Again, example. For example, I want to add 2 numbers. So there is example number 1. Let me give. I am saying x is equals to y plus z, where y and z will be the number entered by the user. Simple statement. How many times it will repeat? Anyone? 1. So can I say it's just constant time? So whenever I want to represent anything in constant, I will write C now. So I am just telling to you all today my keywords. In future, if I'm writing C, automatically understand that I'm talking about constant here. Okay. So it means that here it is repeating just a single time and it will print me the value as X. So here the time complexity is big O of 1. This big O of 1 represents a constant time complexity. Constant time complexity. Correct? So this is the way to represent that it is repeating only a constant number of time. Doesn't matter 1, 2, 3, 10, 20. Constant means constant. There is any number which is constant. That's why the time complexity is big O of 1. Fine, everyone? Making sense to everyone? Okay, perfect. I think everyone is fine until now. As far as I can see the chart window, superb. Let's move ahead. Example number 2. Now let's see who will tell me the answer. Example number 2. Here, what I'm trying to do is that I'm taking the same statement again, but I am doing little bit change here. Try to see the changes now. I am using one for loop. Now, again, when I am talking about analysis module, I am repeating the statement again. Please don't focus on the programming language. Whatsoever I am writing in a way that everyone will be able to understand. Loops are loops here, right? So we are not doing any implementation. We are just seeing that given a code, how we'll be able to find out the time complexity. So consider that I am using one for loop here. Okay. For loop value will start for I in, or maybe let me write like for loop value will start from 0 and it will reach until n minus 1. Inside this for loop, which I am using here, what I'm trying to do is that, here is that I am again writing the statement x is equals to y plus z. Now, I am having this first statement. This is the second statement. Again, check how many number of times this first statement will repeat. First statement, only one time. Perfect. Now, how many times the second statement will repeat? N times. Why? How basically for loop will work? For loop will start from I equal to 0. It will go inside and execute the statement x is equals to y plus z. Then I value will become 1. Again, the statement will get executed x is equals to y plus z. Until so on, when the value of I will become n minus 1, we will again repeat the statement x is equals to y plus z. In total, how many times we are repeating the statement? We are repeating the statement n number of times. And that's the actual functionality of a loop. Why loop came into picture as an initial phase? Their developers have seen that in order to repeat the same thing, they are using a same statement again and again. That's where they have think of these looping things. That why not to create something like a loop where if I will write that single statement, it will repeat a number of times. And the task will be done without writing much statements in the code. Now here if you will see, in total, I am running the statement n plus 1 number of time. Can I say? So now one thing that you have to understand here. We are talking about approximate answers. So we are not taking care of +1, +2, +3, any constant term. In a nutshell, when the value of n is very high, at that point of time, does that matter to add +1? No. So it means that the time complexity will be big O of n. Here the time complexity will be big O of n. This is how basically for any given code, we will be able to examine that how many times statement will be executing, and then we will be able to get to the solution. Suppose there is some statement where you are getting something like n square plus n plus 1. I will show you in the next part. So Big O will say that don't take care about these lower quadratic terms, lower terms. Always take the higher coefficient and move on. Because we are talking about, again, approximations. We are not talking about the exact answers. So at that point of time, you can directly say big O of n square. Correct? Similarly, if you are getting some higher value like n cube, you will take that particular number and write it as a big O. Big O indicates that we are talking about the approximations here. Fine to everyone? Example number 3. All set? Example number 3. Now let's see who will give me the correct answer. Now everyone knows how we can calculate. Everyone sees that, right? Yes, we need to calculate the time complexity for every code. Yes, Kiran, all the notes will be given to you. Please don't take care anything apart from the session that we are doing here, right? So as a repetition, what we are trying to do here is that whenever you're talking about a priori analysis, it means that we are talking about order of magnitude. What is the meaning of this? That number of times any statement is executing. Now, this particular thing you always have to take in your head. So here, if you will see as a very first example, I am having single statement. So it is running only single time. So the time complexity will be constant. And to represent a constant time complexity, it will be big O of 1. This is the way to represent that. In example 2, what we are trying to do is that we are taking one single statement, but after that, if you will see, I'm using one for loop, which will make the statement run n number of times. So overall, it will be n plus 1 time. So what is the bigger number here? N. So you can take big O of n. Similarly, if suppose in future, something like n square plus n plus 1 times will come, I will show you. Let me show you the example and then we will talk about this thing again. So let me remove this. With the help of example, let me try to show you what does that mean. For example, I am saying x is equals to y plus z. Okay, single statement. Inside that, I am making one for loop whose value will start from 0, will go until the value of n minus 1. And again, I am saying x is equals to y plus z. Fine, everyone? Now, inside that, I am making one more for loop whose value will start from 0, will go until the value of n minus 1. Inside that, there is one more for loop whose value will start from maybe 0, will go until the value of n minus 1. And here, I am saying again, x is equals to y plus z. Now, how many times? This is statement number 1, statement number 2, statement number 3. How many times statement number 1 is repeating? 1. Statement number 1. 1 time. Perfect. How many times statement number 2 is repeating? N times. Because here, if you will see, as of now, we are having a single for loop whose value will start from 0 and will reach until the value of n minus 1. Right? Same thing that we have discussed above, right? Now, coming towards the next part. How many times do you think this statement will be repeating? N square. Why n square? If you guys know how nested loop will work, you will be easily able to tell me that this is n square. Not n plus n, it is n square. How? What does this loop indicate? Let me try to show you. Usually how this will work, I value will start from 0. It will go inside the another for loop where the value of j will start from 0. Now, inside that, x is equals to y plus z statement will be executed. Now j will be 1. Again, this statement will get executed. Until the value of, when the value of j will become n minus 1, this statement will get executed. After that, what will happen? I value will get upgraded from 0 to 1. And again, the value of j will run from 0, 1 to the value of n minus 1. And again, the value of x is equals to y plus z will keep on executing. This thing will keep on running until the value of I will become n minus 1. So at every time, if you will observe, it will keep on repeating the statement n times. And how many times this I value will run? N times, n into n square. So if you will see, this repetition of the statements will be n square time. Are you getting my point, everyone? Is this point is clear to everyone? So what is the total repetition of the statements? It will be, can I write n square plus n plus 1. What is the bigger term here? N square, right? So it will be big O of n square. That's it. So simple. Right, everyone? So here we will be able to get this n square. How we will be able to get? Let me, for some students, it is not clear how I am writing it as n square. So let me give you one simple example. Maybe consider that the value of I is equals to, the value of n is equals to 3. Okay. So what will happen? Initially, the value of I is equals to 0. It will run. So it will go for j equal to 0. X is equals to y plus z statement will run. Then j will become 1. Now this j value will run until the value of n minus 1. So this statement will again run. Now again, for j equals to 2, this statement will again run. And after that, it will go out of the for loop. Now the value of I will get incremented to 1. Remember, I is less than n minus 1 is the statement that you're writing. And inside that you're writing condition j less than n minus 1. So that is your condition. For I equal to 1, again the value of j equal to 0, x is equals to y plus z will execute. J equals to 1, x is equals to y plus z will execute. J equals to 2, x is equals to y plus z will again execute. Again, the value of I will get incremented to 2 because it will be not minus 1, it will be less than n, where the value of n is 3. So initially value of I equals to 0, 0 less than 3, 1 less than 3, 2 also less than 3. So here again, the value of j will become 0, 1, and 2. Again, for the statements, it will get executed. X is equals to y plus z. Count how many times these statements are executing now. 1, 2, 3, 4, 5, 6, 7, 8, 9. So when the value of n is 3, the statements are executing 9 times. Can I say this is n square times? Can I say? So can I write if the value is n, it will be n square? This is how nested for loop will work, the way I have showed you. And now, after taking n square plus n plus 1, big O says take the bigger number. That will be considered as the worst case scenario. So it will be big O of n square. For each loop, you should multiply by n times depending upon it should run until n times inside that. Right? Don't cram anything. Try to understand the concept. N is above, right? We need to add all the statements, cumulative. So this is the complete code. So this is 1, this is n, this is n square. So I added all of them. And then I write the approximation here. That's why that n plus 1 I'm adding. Right? Yes, then we ignored that. That's why we have written only n square finally. It's just for your reference, I have added everything. So that in future, if you are revising from these notes, you will get a reference that, okay, how I am getting everything. That's why I'm writing in such a way. Each and everything is very much clear when you will open these notes after 1 year also. Right? Okay, perfect. Fine. Okay, now let's move ahead towards the next example. Shall we go to the example number 4? Everyone ready? Great. Example number 4. Now let's see who will give me the answer. After doing several examples, you will get a command over it. It's as a beginner, might be you are feeling somewhere doubtful, but after doing several examples, and we will do in our live classes, you will just within a click of seconds, after some time, you will be able to give me the answer. Okay. So I'm saying that the value of I is equals to n. Okay. The value of I is equals to n. I am using one while loop here. And inside while loop, I am making one condition. I is greater than 1. Okay. Inside that, I am trying to decrement the value of I minus 1. Now, maybe there is some statement here. Maybe print Priya. How many times the statement will be executed? This statement. Only one statement is there. See, now only I am getting correct answers. Infinite. Who said infinite? Why infinite? So here, if whenever you are doubtful for anything, take some small example. And that is what I will do in every session of mine while explaining to you all. Someone is saying infinite. How infinite is coming into picture? Take the value of n as maybe 5. So the value of I is equals to 5, I am saying. 5 is greater than 1. So internally, you are going internally, I value will be 5 minus 1, 4. And you are printing the name as Priya. Fine. Now your value of I will become 4. Condition is satisfying. It is going internally. I value will become 3. And again, Priya will get printed. Now, I value will become 3. Again, 3 is greater than 1. Condition is satisfying. I will become 2. And Priya will get printed. Now, I value is 2. 2 is greater than 1. Go internally. I is equals to 1. Priya will be printed. Now, I is equals to 1. At this point of time, 1 is not greater than 1. So this condition will not be satisfied. So when the value of n is 5, how many times Priya is printing? 1, 2, 3, and 4. It means it is going 4 times and repeating the things again and again. So when you are having n number, it means that inside your code, n minus 1 times, same thing will be repeated. So can I say that the time complexity will be big O of n? Approximations we need to take care of. Why to take care of plus 1 or minus 1? Simple. Correct, everyone? Got the point? Perfect. Let's talk about example number 5. Let's see who will give me the correct answer now. Anyhow, I got several correct answers. I'm very much impressed with this batch. So example number 5. Perfect. Let's see. Here, what I'm doing is that the value of I is equals to n, while the value of I is greater than 1. What I'm trying to do here is that I am saying I is equals to I minus 3. I is equals to I minus 3. And inside that, I am printing something. Maybe let me print the name of some other student now. Why to print again and again my name? Pradeep. Who will tell me what is the time complexity here? So fast. Now people are becoming genius. Spend your time, take your time. I'm saying, firstly, don't give me the approximate answer. So as it's a very first class, today I'm expecting you to give me the number of times this statement is repeating. First of all, tell me that. Then I will see big O thing. N by 3. It's correct. Whosoever is saying other than that, it's wrong. This statement will be repeating n by 3 times. That is correct. Why is that so? Again, take one simple example. Suppose the value of n is equals to maybe 9. So 9 is greater than 1. So I is equals to 9 minus 3, 6. Pradeep will be printed. Fine. Now I is equals to 6. Condition will be satisfying. I value will become 6 minus 3, 3. Again, Pradeep will be printed. 3 is greater than 1. So I is equals to 0 now. Again, Pradeep will be printed. How many times Pradeep is printing? 1, 2, and 3. How this 3 is coming up? N is equals to 9. 9 divided by 3 is 3. For any of the example, if you will take, you will observe it is repeating n by 3 times. And because it is n by 3, so time complexity will be big O of n. Right? Everyone? If n is, here it is odd number. If it is even, then also, if it is correctly divisible, it's fine. Otherwise, it will take the lower bound of that. Okay. Wait. 9 minus 3, 6. 6 minus 3, 3. Yeah, it's fine, I think. I think it's fine. Anything which is troubling you? It's fine, right? It's 3. Okay. This is what you are saying. Yeah. 3 times it is repeating. It's okay. It's okay. Yeah, I got it. Fine. Shall we move ahead towards the next example? If n is 5, then what will happen? What will happen? When we divide the number, it will give the lower bound. Lower bound of that number. That's it. So 5 by 3. What is the lower bound of that? Anyone? Right? So only one time it will go inside that and will print the value as Pradeep. So 5 is greater than 1. It will go inside that. I is equals to 5 minus 3, which is 2. And Pradeep will be printed. 2 is greater than 1. Now here the value of I will become negative. So that's where only single time it will keep on iterating. Fine. So that's why it is order of big O of n. Shall we move ahead towards the next part? Lower bound meaning that when you are dividing any number, for example, 7, you are dividing by 3. So what is the lower value before decimal? When I'm saying lower bound, before decimal, what is the number that you are getting? Is the value. Upper bound meaning is that you are increasing that number by 1. Okay? Yes. For n is equals to 5, it is also again order of n. Right? Okay, fine. Now, as a nutshell, one note. By seeing several examples, one thing that we have understood. What is that thing? What is that thing we have understood here? We have understood the very first important thing is that whenever someone is talking about time complexity is loop only, nothing beyond that. Can I say? Time complexity is loop only. Means whenever in a given code, someone is giving to you any of the code, what is your main concern in the code? Whenever you are finding out time complexity, your main concern is that whether a loop is present in your code or not. If a loop is present, means the time complexity is very high. Higher the loop, higher the time complexity. So that's why you need to avoid many loops in your code. One inference that you're taking from this session, right? So whenever we are writing any of the algorithms, we will try to avoid the loops, the very first thing, right? And when I'm talking about loops, this is not only loop, but I'm also talking about a bigger loop. I'm talking about a bigger loop here. What does that mean? You remember that example where we got n square plus n plus 1. So n plus 1 is not that much concerned to me. Bigger loop is concerned to me, which is n square. That's why I was getting the value as big O of n square. Another important inference which I am getting from this particular part until so far, whatever we have studied, that if suppose in a code, if there is no loop at all, consider that there is no loop at all, what should be the time complexity for that code? Who will tell me the answer? Constant, which is represented by big O of 1. Constant. Perfect. This is the key takeaway of whatsoever we have discussed so far. Any doubt? Anyone? Before we will move ahead, please ask. Narendra, please ask.
No, ma'am. As for now, I am clear with everything.
So please don't raise the hand. Those only raise
Sorry,
the hand
actually, I did
who
not
have the
hear.
doubt.
Sorry.
Vikas, do you have the doubt?
Yes, ma'am. In the last example.
Yes, please say.
For 5, I think it will execute 2 times. First, it will check for 5, then it will check for 2. So Pradeep will be printed 2 times.
Just give me a second. So 5 is greater than 1. 5 I is equals to 2. 2, yeah, it will print 2 times. So it is taking the
So-
upper bound.
Yeah.
Yep, it is fine. So here it is repeating. You are saying it correctly. 2 times Pradeep will be printed. Thanks for letting me know. And then we will be getting a time complexity as big O of n. Yes, we will discuss the time complexity for log of n, and don't worry, we will talk about more examples here. Okay. Preetham? Doubt?
Hello,
Yes, please ask.
can you please explain the upper bound and the lower bound once? Because I'm confused in that.
Okay, so when you divide the value 10 by 3, what is the answer you're getting? Can you can do it with a calculator as well.
3.33.
3.33.
Yeah.
So when I'm saying lower bound, it means that remove this decimal part.
Okay,
So what is the value?
We have to take only 3 before the decimal.
Before decimal. What is the value?
Okay,
3.
3. Yeah.
Upper bound means take
Upper-
one more. Add 1.
So,
4.
okay. Oh, acha. To the result, we will add 1.
To the majorly that before decimal part.
Okay, so
Fine.
if we got some result like 1.2, the
Huh.
upper bound will be 2
Yes.
and the lower bound will be 1, right?
Correct.
Okay.
It's
Got it.
just we are doing a round off here
Hmm.
in the upper bound.
Okay.
Fine?
Okay.
Okay. Fine. Abhi.
Can you repeat the node points? Whereas you have written 3
Okay. So basically, until so far, whatever session we have taken until so far, I think from past 1.5 hours, what we have inference, what inference we will be able to get. First inference is that we have understood by taking some examples that whenever we are talking about time complexity, which is what we are finding out in terms of big O, it is nothing but loop only. That whenever you are getting in a code for loop or the while loop, you will be having some sort of a higher time complexity. Now, in a loop part also, it might be the case that in one code, you're getting multiple loops. So you need to take care about the bigger loop. For example, in our case, one example we have seen where we are having, I think, 2 loops. One is running n times, one is running n square times. Right?
Yes, sir.
So we are taking care of that higher loop. So that is what second point says, which is perfectly fine, making sense also. And third point says that if there is no loop at all in my code, at that point of time, the time complexity will be constant. This example also we have seen. For example, go to example number 1. There is no loop here, right?
Oh.
So we are having a constant time complexity.
So to get the time complexity, so we mainly focus on the loops, right?
Exactly. That's what I want to infer here.
Okay. And we'll focus on the statements, right? To get the how
Yes.
many times
Number
it
of
is.
times that these statements are executing. That is what you need to focus on. So
Okay.
obviously,
Now-
when you are having a loops,
Yes.
it will looping, it will making repetition more number of time. That's why the time complexity will be high. So by saying the second point, the simple meaning of writing that point is that suppose in a code you are having multiple loops. For example, in example number, I think 3, you are having one loop here, you are having another loop here. So at that point of time, you need to understand what is the higher number of loops and what statement. Here it is running only n times. Here it is running n square times. For example, in this code itself, I will write another statement which is running n cube times. So you need to take care of the higher value loop, which is n cube. In this case, it is n square. That's why the time complexity is also n square.
Okay.
Right?
Okay.
Fine. So here, until now, we have discussed time complexity. Its space complexity is not that much bigger task to discuss about. When we talk about the examples while doing the implementation, I will show you that whether we are using any extra space or not. In these examples, we are not using any extra space. So the space complexity is big O of 1, which is a constant space. When specifically I will use any extra space, then at that point of time, I will demonstrate you, and then you will be able to get the better understanding of the space complexity. As of now, whenever I'm not discussing any space complexity part, consider the space is constant. Consider that we are not using any extra space at that point of time. So when we are not using any extra space, the way to represent is again same, order of 1. So in all these examples, time complexity is varying, but space complexity is same, which is order of 1. Making sense to everyone? Okay, perfect. Now let's talk about another example. We are not done with analysis. We need to do more examples, right? So now let's talk about example number 6. Let's see who will give me the correct answer now. Example number 6. Here, what I'm saying is that the value of I is equals to 1. And I'm writing one while loop. While I less than n. Inside that, I'm saying I is equals to 2 times I. And then I'm printing maybe the value of I itself. Who will tell me the answer? What is the time complexity? See, you guys are writing the answer within seconds. So take your time. That's why maximum students are writing it wrongly. Now I want quality over timing. So don't take superior decisions and then give me the wrong answers. Take your time. I just told you the approach also. If you're confused, take some random number value of n. For example, you can take the value of n as 64. Try to solve that. Try to see how many number of times the statement is repeating here, and then give me the answer. I'll come back within 1 minute. So many different answers, variety of answers I am seeing. Okay. But this one answer amazed me, which is infinite times. I don't know why you guys are so fond of infinite. Big O of 1, constant. Wow. Square root of n. Okay, let me try to show you, and then we will just whosoever is writing everything, just try to see whosoever approach is correct. That's good. Whosoever is facing some trouble or is having some issue with the approach, try to see where you are lagging. Okay, try to do the analysis of your own self. So here, what we are trying to do is that the value of n is equals to 64. Right? Now, value of I is equals to 1. So 1 is less than 64. Yes, 1 is less than 64. So what will happen? I value will become 2. Correct, everyone? Now, 2 will get printed. Now what will happen? Again, 2 is less than 64. So here, if you will see, the value of I will become 2 into 2, which is 4. So 4 will get printed. Again, 4 is less than 64. So the value of I is equals to 2 into 4, which is 8. I hope I'm making sense to everyone, right? So 8 will get printed. Now, again, the value of 8 is less than 64. So now again, 8 into 2 is 16. So I is equals to 16 here. 16 will get printed. Next step, 16 is less than 64. So I is equals to 32. 32 will get printed. 32 is less than 64. I is equals to 64. And now 64 will get printed. Right? Now, when 64 will go, is this less than 64? It will come out of the loop because this will not run. See, how many times this statement is executing? 1, 2, 3, 4, 5, and 6. You can try with some other numbers as well to get a check that what is the intuition behind getting 6 for the 64 number. Here, if you will see, if I will try to show you what is log of 64 base 2. Is anyone can answer me? How we can solve this number? You can write log base 2 to the power 6 here. So you can write like this. Can I say it is 2 to the power 6? So while doing a logarithmic, this power term we can take upfront. So 6, we can write this same number like this as well. Log 2 base 2. And this value is equals to 1. 6 into 1 is 6. And this is why you are getting 6 number of times. Meaning what I want to state here is that here the time complexity will be equals to big O of log of n base 2. Why base 2? Because you are multiplying again and again by 2, by 2, by 2, by 2. If suppose I will change this number, this statement from I equals to 2 into I, from this to this, then you will observe that your time complexity will be big O of log of n base 3. Getting my point? Everyone? Again, it doesn't matter whatsoever base is there. We are talking about approximations. So we can write simply as big O of log of n. This is also correct. Simple. But it's just to show you the reason behind the base factor. I just talk about that. Is this fine for everyone? Is everyone following me? Correct? Perfect. Okay. So let me give you one more example. And we'll see who will give me the correct answer now. What we can take is, here suppose the value of I is equals to n. So whatsoever things I am talking about here, I will share with you all these examples and the notes. And obviously you will be able to get the pre-recorded sessions as well. Still, after listening those recordings as well, if you still have any sort of doubt, please do ask. And you can ask from the support section or maybe from me before starting of the session in the tomorrow's class. And then we will try to resolve those doubts first, and then we will move ahead. So the value of I is equals to n. Here what we can do is that while the value of I is greater than 2, what is happening? I is equals to I to the power 1 by 2. What is the time complexity of this? Take your time, try to solve it. Let's see who will give me the answer. Shiva, it is why it is not big O of n by 3. You can write it like that as well. But big O means we are talking about worst case scenario. At that point of time, it doesn't matter whatever be the constant number you are dividing, adding, or multiplying. That's why in terms of big O, we are writing it as a number which is a factor, like which is changing. So here it is n. So that's why we're writing as big O of n. Right? Again, one good way to solve this question is take some value of n, maybe 64, maybe 256, any of the value. So last line is power of I is equals to I to the power of 1 by 2. So here if you will see, what we are trying to do is that 256 is the value of I, which I am assigning here, right? The value of I is equals to 256 here. Now, this 256 is greater than 2. Fine. So the value of I will become 256 to the power 1 by 2. Can I say? Can I say this? Okay. Can I write this 256 in terms of 2 to the power something? Or what is the square root of 256? If directly you can tell me. Yes, 16. So we got 16 here. Now again, 16 is greater than 2. So I is equals to square root of, so 16 to the power 1 by 2. What is the value? 4. Right? 4 is again greater than 2. I is equals to square root of 4, which is equals to 2. And here, when we get 2 greater than 2, here it will stop. Can I say? So here if you will observe, this particular thing is running how many times? 1, 2, and 3. Only 3 number of times, right? 4th time, it will stop. It stops. Okay. Now here if I will try to see, it's quite, I would say, difficult to understand which particular part it is showing to me. Because for the value of n is equals to 256, it is running until 3 times. So it's not forming like a logarithmic series also. We need to understand in much more depth. So for these kind of questions, there is some trick. What is that trick? Try to understand. At every point of time, what you are trying to do is that you are trying to do n to the power 1 by 2. You need to calculate until what point of time, what is this value of k, for which I will keep on dividing it by 1 by 2, 1 by 2, 1 by 2, there comes a point when this value is equals to 2, which is a stopping criteria. Can I write this statement? Please see this particular part very much carefully. If you will see here, what we are trying to do is that when the value of n is 256, what we are trying to do is that for the first part, we are doing 256 to the power 1 by 2. For the next part, we are doing 256 to the power 1 by 2 to the power 2. For the next part, again, we are trying to do 256 to the power 1 by 2 to the power 3. We are keep on dividing the number by 1 by 2, 1 by 2, 1 by 2 until so on, until the value is equal to 2. Because at that point of time, your code will stop or your code will terminate. So here at the value at 3, when the value of k is 3, my code is terminate for the value of n as 256. Can I say this? Can I say this? So consider that 256 as n. Can I write this statement? Now you can easily calculate what is the value of k. What you can do? You can take maybe log 2, so log base 2 both sides. So here it will be log base 2 n to the power 1 by 2 to the power k, which is equals to log 2 base 2. Now this power term can come up front just like the way we did. And we will be able to get log of n base 2 here. And this value will be equal to 1. Now I can take this 2 to the power k towards the right side. So it will be log of n base 2, which is equals to 2 to the power k. We can again take log base 2 on both sides. So the value will become log base 2, log n base 2, which is equals to k will come up front, log of 2 base 2, which is equals to 1. So here the value of k will become log base 2 log base 2n. And this is nothing but is the time complexity. So this is nothing but is big O of log of n. Correct? Because see, whenever we are having the values and we will be able to just according to using our head, we will be able to examine that it should be n by 3 or n by 4. We will be able to analyze the pattern until so far, until example number 6. It's fine. It's a good approach. But when your problem will become complex, at that point of time, if you will not able to get an idea that what is the relationship between this 256 and 3, I don't know. So at that point of time, the way I just showed you the approach is the good way. Where at any point of time, if you will feel struggle, you can just do that. What should be the value of k? Until that point of time, I will run my code. That is what I need to find out. I need to find out the order of magnitude. I need to find out how many number of times I'm repeating the statement. And we can easily able to do so by calculating the value of k, by checking what is the stopping condition, and we can solve that. So here, what we are doing is that, first of all, is this part is clear, how this is coming up. Stopping criteria not clear. We are saying, what is the criteria? When the value of I will be equal to 2, at that point of time, it will not go inside this particular statement. Can I say? When the value of I is equal to 2, at that point of time, it will not go inside this statement. Can I say this statement? Correct. You can refer this example, which is written on right hand side. For 256, when the value will become 2, it is not going inside the statement, right? Okay. So it means that what we are doing is that we are keep on at every point of time dividing the value by 1 by 2, 1 by 2, 1 by 2 until k times. We need to find out how many times this k, what is the k value? How many times this keep on repeating? At what point of time this will stop? When this value will be equal to 2. Is this part is clear to everyone? This first statement I'm talking about. After that, I will show you the calculation. Fine. If it is fine, now what you can do is that you can take log base 2 on both sides. This k is saying, so here if you will see, at every time you are dividing it by 1 by 2, right? Am I saying it correctly? So this k is saying that how many number of times you will keep on dividing. How many number of times I want to find out, I will keep on dividing. How many number of times the statement will run. So this is k parameter which we want to find out. How we decide we need to take log base 2 both sides? Because I want this value to be 1. How this value will become 1? When I take log base 2. Because I know the logarithmic property which says that log 2 base 2 will be, value will be 1. That's why I take log base 2 on both sides. So when I take that, I got this value as 1. This is what I want. And now we know that in the logarithmic property, it says that the power term we can take upfront. So 1 by 2 to the power we take upfront. It will be log of n base 2 equals to 1. Now this 2 to the power k, I can take it towards the right side. That's what I did. Log of n base 2, which is equals to 2 to the power k. Done. Now again, what I want is that I want to get rid of this 2. So I am having log of n base 2, which is equals to 2 to the power k. Now what I can do is that I will again take log base 2 so that I will get rid of this 2. So if I will take log base 2 here, so see what will happen. Again, power term we can take upfront. So k will take upfront. Log of 2 base 2 will be here. And here we are having log of log of n. Now again, this value will become 1. Because my overall objective is to find that value of k. And the value of k will become log of n. And that is what I want to find out. And that's the order of log of n as the time complexity. So it will be base 2. Yes, please see, analyze, and then ask me the doubts. Rooney, please ask the doubt.
I wanted to ask how any real-time example could you give where we can think of applying any algorithms? You can think about in terms how we should decide. So these are the just a number of numbers we are trying to achieve. We are executing a loops. So any real-time example where we actually want to design an algorithm?
We will see that. As of now, we are just focusing on that analysis module. So when I will talk about the second part, designing of that algorithm, there you will see applications only. But why I am talking about this as a first and then I am talking about designing part? Why? Because I want you guys to know that when we design the application or when we see the real-time applications of those things, when at that point of time, if I will tell you that, okay, tell me, Rooney, what is the time complexity you are getting? Is this the optimized version? Then you will, at that point of time, what you will say? How do I know? What is the time complexity? I just know how can we design? So that's why if you will initially know that how given a code, so here you don't need to take care of anything, that how basically we're writing the code, how it is coming up. Everything is coming or making sense in the future classes. But here you just need to know one thing, that if in future someone is giving you any set of code, are you able to find out the time complexity of the same or not? That's the only thing you should know as of now.
Okay.
Real-time applications, there are so many, and that is what we will discuss in our course completely when we talk about designing part.
Okay, and second question is the third step, which you have 1 by 2 is to k, log 2n is equal to 1. Then how are you deciding to take 2 is to k on the right side?
How you will calculate the value of k? You can do it so don't go with my steps. The question is that you need to calculate the value of k here. How will you do? So you have this equation, mathematical equation, which is 1 by 2 to the power k log of n, right? Base 2 is there, which is equals to 1. I'm giving you this equation and I'm saying to you, calculate the value of k. How will you do? You tell me.
Okay, so we need to take something which equals on both sides and then move forward.
Yes, that's the only way. So whenever we are talking about DSA, one thing which I usually say to everyone is that you should be good with maths. If you're good with the maths, you're good with the numbers, you just love the calculations, the mathematical calculations, you will be easily able to do these things, right? So here it's just a mathematical equation. It might be the case that your approach is somewhere different to get the value of k. I'm completely fine with that. But the answer should be same. Right?
Okay. Yep. Thank you.
Okay. Yes, Satyam. Satyam, do you have doubt?
No, ma'am.
Please lower down your hand. So those who raise your hand, I am expecting everyone is having doubt. If you don't have, raise your, down your hand. Rooney, please, you already have asked the doubt, so that it won't be confusion for me. Yes, Kashyap. Satyam, you can mute yourself.
Hello?
Yeah, please
Is my
ask.
voice is audible?
Yes, perfect.
Yeah, in example 6, madam, you took by log, right? So when I did
Example
the same,
6.
Yes.
Okay. Yes, please say.
So in example 6, I did same. I took n is equal to 8. So I got only a three. Only I got. Wait. Okay. So I got only 3 results. So while big of n, I got a result. So I didn't understood why you have taken log on that. So will you please just
What
tell
is
me
your
that?
question? Can you repeat your question? What you took as a n in your example?
And my question is regarding, so even by solving we can able to solve it with big of n. So why you take log? I didn't understood that part.
Where is big O of n?
No. In last previous examples, we just solving by using big of n. So suddenly we just came across with log part.
So here, what I am trying to show you, that time complexity is not only about big O of n. You can also get different kinds of time complexities like log of n. And how you can get so, I am giving you the examples of that. Here, if you will see why it is not big O of n, because here the statement is repeating until log of n times, not n times. Why it is log of n? In this case, because here the statement is executing log of n times. So I am trying to show you the different kinds of examples which you can encounter when we are talking about the real implementations. So for that, I'm just showing to you different varieties of big O.
Okay, we can able to solve in only by even by big of n, right? Hello?
This question we can solve only with the help of log of n. Why big of n? What is the meaning of big O of n?
So
what is the meaning of big O of n? So when I am saying that this is executing big O of n, what does that mean?
Worst case scenario.
This meaning is that this statement x is equals to y plus z is executing n number of times. That is the meaning of big O of n. When I am saying order of n square, it means that at max n square times the statement is executing. In every example, we are just trying to see that how many number of times the statement is executing. In the below examples, we are seeing that it is executing log of n times or log of n times. In the tomorrow's session, we will try to see the complexity classes, where I will show you starting from scratch to the very end that what is the order of the complexity classes, which is having a lower complexity or which is having a higher complexity. Do we need to learn logarithmic to understand DSA? Yes, you should know basic properties of logarithmic that we usually have in our 9th, 10th classes. So if you will talk to me how much mathematics is required when I'm saying maths is required, it's just the 10th, 11th, 12th, 9th to 12th basic maths is required. That is must. If you will say to me that I don't know the basic logarithmic properties, then it will be difficult for you. Calculus is not required. Whatever part we want to cover up as of now. Calculus in terms of differentiation, integration, that part is not required. Yeah, vector algebra is enough. Right? Simple basic maths, AP series, GP series. What is the sum of GP series? What is the sum of AP series? I hope everyone remembers these things we used to understood when we are having lower classes of in mathematics. Those things you should remember. If you don't remember, then also it's okay. We will when I will cover up, you will be able to get a revision of that. Right? Any other doubt? Yes, Raj Shekhar.
Hello.
Please
Yeah, so
ask.
for example 7, when we are trying to find the value of k, so we have taken a stopping criteria as a 2 because we have mentioned in the while condition I is greater than 2.
Correct.
Suppose that if I mention I equal to 2 or maybe I greater than 1, if I mention that,
then you will written here 1.
so stopping criteria will be 1, right?
Yes.
So in that
definitely.
case, the time complexity, the value which we are getting for the k will change, right?
Yes. Yes.
Okay.
Yes.
Yeah, that's
Okay. So those who already asked the doubt, please lower down your heads. Avinash.
Am I audible?
Yes, yes. Please ask.
Yeah. So this example 6 and example 7. In example 6, we saw that we are getting a big O of log n, right? And in the example 7, we are getting big O of log n, right? So I understand these are two different questions, but if we talk about the complexity or the time complexity, so can we say that the answer 7 is better optimized than
Yes.
64?
Yes.
Is that what it means?
Yes, you can say that. And this thing only, like what is better optimized word. So tomorrow class, everything will be clear where I will talk about complexity classes. So what is the different set of complexity classes you have? So in the increasing order, I will write it down. Then it would be better. It will be better clear to everyone. But whatever statement you said here is correct.
Okay.
This is more optimized because this is having a lesser value as comparable to the above one. So if you will solve some number by taking log and by taking log of log, so log of log is having a smaller value as comparable to log, right? So that's why. So, but if someone is not getting the point, it's completely fine. In tomorrow's class, everything will be pretty much clear. Any other doubt, Avinash?
No, thanks.
Okay. Anuj.
Hello, ma'am. Am I audible?
Yes, yes, yes.
Yeah, so I want to validate the approach that we are taking in the 6th and 7th example. So we are trying to get here, we take in 7th example, we took 256 as n, and we are trying to find how many times the while loop is correcting itself, means running until I is greater than 2. So we are breaking it down to n is equal to 256, and we are trying to find the number of times the loop run. So it is 3. So we are trying to check how many, we are trying to build a relationship between 256 and 3 by
Exactly.
using this at the condition I is equal to the inner loop condition I is equal to I raised to 1 by 2.
Correct.
So that's how we boil down the equation n raised to 1 by 2 raised to k is equal to 2. 2 is that
Exactly.
the stopping criteria. That
Exactly.
is how many times the while condition, the condition inside the while loop corrects itself and when it stops.
Perfect.
So we are
Correct.
breaking it down. We are approaching this way. Can there be more approach, or we will
No.
see while solving other examples?
So this is the ultimate approach which I am talking about here, because other approach is that, is there any someone who will be able to get a guess by seeing the numbers itself, by taking multiple trials? But I feel that for this question, that is not a efficient one. By going like this, it would be better. So that is the most efficient approach here.
Okay. Yeah.
Okay. Okay. Any other doubt?
No, ma'am.
Sai?
Yes, ma'am. I have a doubt. We are for the analysis, we are prioritizing two, right? Space and time complexities. If a problem statement has the solution with less space complexity and more time complexity, and the another process have the more time more space complexity and less time complexity, which one is best to choose?
Who will give me the answer? We already discussed this point. Who will give me the answer? Time complexity. See in the chat window. So we already discussed this point. Maybe you might join late, that whenever there is such kind of a trade-off, we always go for lesser time complexity, even though space is high. Any other doubt?
Yes, ma'am. We got a LCO bundle from LCO for the courses, right? Actually, I'm using Linux OS. I'm unable to play those videos, ma'am. Is there any solution you know about it?
Can you mail me? My email ID is priyabhatia@iniron.ai with your full name, with the name that you enrolled. I will connect with the team.
Okay.
And write down the problem, whatever you are facing, clearly in the mail so that I can forward to them.
Okay.
Fine?
Yeah.
Any other doubt?
No. Thank you.
Okay. Rajbir.
Yeah, ma'am. Ma'am, I have no doubt, but it's I want to take clarification. I just have alternate thought about looking at the code. We can say it's order of n or log of n. I just want to confirm. So if there is a complete iteration equal to n number of time, we can say it's a order of n. And if there is a drastic reduce or reduction in the iteration, we can say log of n. Can we say that, ma'am?
Don't do like this. See, for some things, it might be valid. For some code, if you just take all these things in your head and directly write log of n or order of n, you might be in trouble. Always go with the steps like the way I am telling to you, and don't be generalized anything. Don't generalize anything here. This is what I am saying.
Okay.
Go with
so
the
I
steps.
mean, the only way is calculation at the time of.
Yes. That's the only accurate approach. There is no shortcut here. If there is any generalization, why I took 2 hours of the session. I can simply write one line and I can tell to you all that when you find this thing, write O of n. When you find this thing, write log of n. No, it's not like that.
Got it, sir.
Okay.
Thanks, ma'am. Yeah.
Yes, Arpit.
Hi, Priya. Just wanted to ask, this stopping criteria technique that you told about, can we use this for every problem?
Yes, but for those problems, because the things are very easy, we easily able to guess. If you're not able to guess, you can use anywhere.
Oh, so can you take one example where we have used this before, while I is greater than 1 and we subtract I equals to I minus 3? So
Still,
can
the examples are not completed. There are so many problems which I want to which I want you guys to practice. Some of them I will give you as an assignment, and some of them we will discuss tomorrow. So after that, maybe all these things will be clear to you with the examples. So examples part is not finished yet. Let me tell you all. So we will discuss that point. It's not only the single one which I am discussing here. We will discuss more. Okay, so that is homework. Should I give here itself in the PDF, or do you want a separate file? Let's take here itself. Okay, I'll see if I will upload there also. So the very first question as your assignment, which you need to practice, and tomorrow when we will come to the class, that is the first question that we will discuss. So that is I is equals to n, while the value of I is maybe greater than 2, and here I is equals to I to the power 1 by 25. Okay. First thing, so you need to tell me, so suppose here there is a print statement of I, you need to tell me what is the time complexity of this question. Secondly, if suppose we are getting maybe the value of I is 29, while the value of I is less than n. Okay. And so here I is equals to I to the power 23. What is the time complexity of this? Try to do at your home. After that, I is equals to 1, while the value of I is less than n. I is equals to 2 into I, and I is equals to 3 into I. These are the three questions, okay, which is based on the, again, the analysis that we did today. So whatsoever things we have covered up today, right? The way, the approach, that the kind of approach that we use today, same kind of approach you need to use here for all these three questions. We'll start with that, discussing these questions. Let's see who will be able to give me the correct responses for these three, and then we'll see, right? So I think here n is any random number which you can choose from yourself. So let me do one thing here. Let me first of all import this file. So what I can do is, this is a new DSL live batch. And today is the lecture number 1. Lecture 1, live notes. I will share with you these notes just now so that you will not wait for the team. Anyhow, they will upload the things, but instantly you will be able to get from me so that you can do according to your timings. So let me upload it in the drive. Perfect. So this is the link from where you can extract the notes. I hope it's accessible. Can anyone confirm this? So these are the today's live notes. Perfect. So what we can do is now just take your time. Okay. I'm ending the today's session. Try to solve those 3 problems. And then in tomorrow's class, before coming to the session, so I used to join 5 minutes before. So I request everyone, first of all, come on time. Those who have the concern, join 5 minutes before. I will be there. We will discuss your concerns. We'll start the session. After that also, we will take few minutes of time, 10-15 minutes after the session as well, just like the way we did today as well. So just like the way we did today, we discusses all your queries if you have. Okay. Required maths topic is just logarithmic properties as of now. Focus on that. Remaining, if any resources or anything which you required, I will let you know, or I'll share by myself. You don't need to worry. My email ID is Priya Bhatia@ineuron.ai. So if you have any doubt, you can mail me also personally. I will mail you back. Okay. So I think so far so good. Session is good. Everyone able to understand the session? Yes, going great. Perfect. That is the spirit I want until the end of the session. Thank you very much. Bye-bye. Do the thing pretty well. And notes already shared. Now you don't need any dependency on the team also. So all the very best. Bye-bye, everyone. See you soon tomorrow.